Okay, quick reminder on how to do the difference quotient. That was something we did yesterday, and this is just a review. So, if I were going to take this function right here, the black one at the top, f of x is that, then if I were going to do the difference quotient, which is this little formula, it tells you essentially the slope of that curving line in terms of x and h. So there will be an x and an h in your answer if you did it right. Then I need to start by doing this part. Always try to do math just one step at a time. This is your first challenge. So I'm going to write this guy, except with empty spots where the x's are. Do those parentheses matter? Yes, they do, because if you forget a parenthesis, it often means you forget to distribute a negative, which often causes the whole problem to be wrong. So it's worth taking an extra. How long does it take to make one set of parentheses? Is that like even a half a second? It's worth it. Now I'm going to drop in x plus h. Now I know that was a plus sign, so in this case, I didn't need those parentheses, but it's very easy to drop them later if I didn't need them. 4 times, I hope you remembered that this is x plus h times x plus h, and then plus x plus h. All right, then I'm going to actually multiply this part out next, and I will have 4 times x squared plus hx plus 2 hx's actually. There's one for the outside ones and one for the inside ones. And then the last make plus h squared, and then plus x plus h, and then one more, multiply everything by 4. 4x squared plus 8hx plus 8. There's 2 pluses in there, which I don't need. H squared, that's not 8, that should be 4. Sorry. 4h squared plus x plus h. Whew! Here we go. Did you catch me making any dumb mistakes in there, or did you get the same thing? Seeing lots of nods, so it's probably right. Now I need to subtract f of x, so I'm going to go minus, and then what is f of x? Well, that's just what they gave me at the beginning. It's right there, 4x squared plus x. 4x squared plus x. Notice I have it in parentheses, so I'm not going to screw up my negative there. Then it's all over h. So let's see what cancels. The negative 4x squared here, and this 4x squared will cancel. This negative goes on the x, which will cancel off this positive x here. So all the stuff I have circled in red then is canceled. What I have left on the top has an h in everything. H comes out. I got 8x plus 4h plus, wait a minute. Yeah, plus 1 if I take that h out. I took the h out of here and here and here. And that's all over h. And that way the h's can cancel. Final answer, 8x plus 4h plus 1. Raise your hand if you had that one right. Okay, good. That's how you find the slope of a curve. And it depends on x, which is where you want to start. You know, it depends on where you want to start on this curve. And it depends on how far over you go, which is the h part. All right. So that's one thing we learned. Another thing we learned was if I give you 2 functions like f of x and g of x, then I can multiply them, add them, subtract them. And here's some thoughts. First of all, if I was going to just say f plus g of x, do you get I'm just supposed to add the function? So I can just write x squared plus 1 over x. But if you left it that way on the test, I would sadly have to mark it wrong because you haven't actually added them. You've just left me an adding problem. To actually add them, I would need a common denominator, and this one's denominator is a 1, so they don't have a common denominator. Do you get what I'm talking about? This is a top 20 thing, finding common denominators. I do it with just numbers in the top 20 because that's a good place to start. At least you know how to do it with 1/2 plus 3/5 on the top 20. And then if you can do it with numbers, then you have a chance of being able to do it with variables. This guy gets multiplied by, who knows? X, just x? X over x. And now it has a common denominator, doesn't it? Do you get the one on the left now has a denominator of x, and the one on the right has a denominator of x? And what does this all make on the top? x to the third over x plus 1 over x makes x to the third plus 1 over x. That's the two functions having been added together. Okay, that's adding them. Again, it's usually easy to add things unless we make them fractions. Do I need to talk about that more? I can. I can do another practice of that with you if you think I need to. Seeing lots of no's, so I'm assuming you can handle making a common denominator. All right, so I'm going to move to, there was subtracting, that's easy, you just take the one function minus the other function, but what if one of your functions has two parts to it? If I wanted to take g minus f, obviously that tells you what order to subtract them in. Here's g, x squared, minus here's f, x plus 3. I just talked about this a second ago. What did I just do wrong? I forgot the parentheses. When you're subtracting things, be careful. F of x is like a variable, like y. I should replace it with an empty parentheses and drop in what it is. F of x is that. It goes in parentheses. So that would be x squared minus x minus 3. So be careful when you're subtracting them. You don't screw up the negative. Okay? How about dividing them? It's not that complicated. You just divide them. If I wanted f over g, I just put f over g. Here's f, x plus 3 over g, x squared. Common mistake is people think they can cancel an x on the top and the bottom. Why can't you? One little sign keeps you from doing it. Why can't I cancel that and one of those? You can't. Yes? Because it's a plus. If it's an add problem, you can't cancel. Here's evidence. You get I cannot cancel those 3's. Would you agree it's supposed to be 1 plus 3 is 4/3? And if I cancel those 3's, it's not going to be equal to 4/3 anymore, is it? You can't cancel when there's a plus sign there. Now, if it was like this, can I cancel now? Yeah, and think about it. 3 times 5 is 15, divided by 3 is 5. So it's okay to cancel like that. If you're ever not sure, go do it with simple numbers and see, would this work with normal numbers? Then if it does, I could probably do it with variables too. Okay, so there's add, subtract, multiply, and dividing functions. Then what's the last thing on that? That's the last thing is to talk about their domains. All right, so I got to give you one where they actually have domain issues. Would you agree that this function, f of x, most things can go into it, but there's something that would poison it? What would poison it? So the domain is not just -7. That's not the right way to say a domain. The domain is all the things that work. So how could you say it? All real numbers except -7. Okay, good. That's the domain of f of x. Now how about g of x? It is going to have a weakness because it's going to be a square root. Do you agree that most numbers, no, I shouldn't say most, many numbers would work, but there would be many numbers that could screw it up too? All right, so do you remember that on this kind, you say this can't be 0. On this kind, you say this what? Greater or equal to 0. Everybody please write that down because that's part of the question I'm about to give you as the Insta retake one question. It replaces the one question I felt I didn't teach you. It's just like this. It's going to be domains that involve denominators, square roots. Now I solved these two little things. And this one comes out to x cannot equal -7, but I should say all real numbers except x can't be -7. And over here, this one, again, good to put all reals if you're going to say x greater than or equal to -3. All right, so I got my two domains here. What if I put the two functions together? Then what's their domain? You know what I mean? Like, what if I add this function to this function. If I add them together, now what's their domain? All right, my experience tells me that the easiest way to do this is with number lines. Remember me telling you that number lines are a visual representation and people are usually pretty good at seeing it? Like if I say everything except -7, here's a really easy way to show that. Everything except -7. You know what I'm saying? We'll do a number line over here. It's a pretty easy way to see it if I go like this. This or bigger. Again, it's pretty easy to see those two. Now, I've got my two domains written as number lines. This is the domain of f of x. I put a big D. That's the domain of f of x. This is the domain. And you can just put a G to shorten it up. I could just put a little D sub f if I wanted to. I should probably do that because it's less messy. So that's the domain of f and the domain of G. When I add or subtract or multiply, notice divide does have a different issue, but if I add or subtract or multiply these functions, then I got to do something to their domains. Do I add, subtract, and multiply the domains? Nope, it's not that easy. But for adding, subtracting, or multiplying the functions, I got a new function that's got two weaknesses. It can't be -7 or it'll crash this part of the function, and this part can't be anything smaller than -3, like -4 would crash that function. So it's got two weaknesses. It's kind of like parents, these are the parent functions, right? Having a child, you know, some things are passed down from parents. You know, like you might get a propensity to have a heart attack from your dad's side of the family, and you might get a propensity to get cancer from your mom's side of the family, okay? And sometimes the kids are lucky enough to have neither problem, but sometimes you get both. You know what I mean? Like you might have got bad eyes from your mom, and you might have got bad teeth from your dad, and you know what I mean? Like you sometimes you get neither. Like your mom had bad eyes, and yet you got good eyes that didn't need glasses. And both your parents have bad teeth, but yours came out fine. So it all depends. Well, in math, we have to have a system that is always going to work. And so we can tell you that in this scenario, you're going to have both weaknesses. So how do I fix it then? I take these two and I do, what do you think? Union or intersection of these two? If I do a union, do you get then that the only thing that didn't get invited to the party was -7? And that would imply the only weakness of our function would be -7. Do you think that's true? No, it's got both weaknesses. The child of adding these two functions or subtracting them or multiplying them will have, here's the child function. I'll write it for you. I'll use red because it hasn't been used that much up here. Here's multiplying them. 1 over x plus 7 times square root of x plus 3. It's like a combo. That all ends up, when you multiply, you don't need a common denominator. It all ends up as one big fraction, root x plus 3 over x plus 7. It's got both weaknesses. That is not a union then. It's an intersect. So, how do I intersect those two? Remember, intersect means overlap. So here's my favorite way to do these domains. I take this number line, and I put it with this one. I got to be careful of where that -7 is, though, right? Is the -7 to the left of the -3, or should it be more like this, to the right of the -3? It should be to the left of it. So now it's like this. And then I just have to see where they overlap. Intersect means overlap, right? So where do these overlap? those numbers were safe for both the mother function and the father function, so to speak. The two parent functions, both of those things, anything that's in that zone will work for both of them. So final answer, what are safe things to feed this function? From -3 to infinity. Can it be fed a -3 safely? Yes. Can't ever touch an infinity. There you go. From -3 to infinity. All right. That is taking two functions and adding them, subtracting them, or multiplying them. And then what's their domain going to be? All right. What's the one I kept avoiding? Dividing to two functions. Because why? To get when you divide, you create a denominator. When I take this divided by that, whatever's on the bottom, all of a sudden is a denominator. What can't denominators be allowed to be? 0. So even if this function, if that function becomes the bottom of a fraction, it used to be okay for it to be 0. But now, if it's the bottom of a fraction, it can't be 0 anymore. So divide is the one that's different than the other two. So now, I'm going to back up. Actually, I'm going to leave that. But I'm going to go to another page and start with a clean board here and do the divide case. 1 over x plus 7 and square root of x plus 3. This was f of x. This was g of x. There. Okay. Now, if I divide f over g, do you think it matters which one's on the bottom? Oh yeah, it totally matters which one's on the bottom. Okay. If I divide them, I'm going to take the f function, 1 over x plus 7, and divide it by the g function, square root of x plus 3. Do you get it? We used to be okay for this thing to be 0, but now it's not okay for it to be 0. All right, so here's what you have to consider. You have to ask yourself, what's the domain of this original one? I'm going to make a number line for it. Everything except -7. What's the domain of this one again? Things that were, again, I think number lines are easiest. Things that were bigger than -3. All right? So we do overlap those two like we did before, but we have to add a third number line. The third number line is, now that that thing has become a denominator, the third number line is for what is the one thing we're worried about now that the g function is in the denominator. We can't let x be what? -3. We already have got this dealt with that needs to be bigger than -3 also, but now it can't be -3. It used to be able to be -3, but now it can't because it's on the bottom of a function. So the third number line is just about what makes g be 0. So here's how we say it. This one's called the domain of f. This one's called the domain of g. This one's called the domain of f. No, the denominator, sorry. Domain that g cannot be 0. And then you ask yourself, what's the one thing that would make the bottom be 0? Didn't used to have to worry about that. Back when it wasn't a denominator, it could have been 0. So what's the one thing? -3. So now I got 3 number lines to overlap. And if I do it right, I can overlap all 3. And now I've got those 3 number lines overlapped. And what are the numbers that work for all of them? Would you agree that on the ends, the right end, it works for all 3 of them? So I just keep following it back until I hit here. Would you agree that it's pretty similar to what it was last time, except now it's Not greater than or equal to negative 3. It can't be negative 3, but it can be anything bigger than that. There. We learned the new thing for today. How to find the domains of functions that are getting added, subtracted, multiplied, and also how to find the domains when you divide them. That was the most complicated part. What was the key? You have 3 number lines this time. The two parent ones. Those domains are easy to find. You can overlap them. That's what you do for most of them. But you add a 3rd number line. The 3rd number line was what? This guy. It's what would crash this newly developed function by making g 0. So you have to ask yourself, g used to be able to be 0, but now it can't because it's on the bottom. And this number line just finds what makes it negative 3. Common mistake is people think, oh, and it also can't be negative 10. So they try to think all the things. You know, all we want for this number line is what makes it 0. We already got the other domain for g here. This is domain of g already. We don't need to worry about how it can't be negative 5 and negative 10. So the new number line just is about what makes the bottom function 0. All right, to see if you really understood that, I'm going to give you one right now. And I'm going to have you do the divide case and see if you can do it. Okay? Now, I'm giving you one that's a little complicated just because it's not complicated. What the heck is the domain of G right now? Think to yourself, how could I crash it? What if it can't crash it? What's its domain then? All real numbers. All right. Now, what if the question was, find f divided by g, and then find its domain? I'll pause for a second while you figure out f divided by g. That's easy. But then what's the domain of that? You'll have to overlap 3 number lines to see where they intersect. I'll pause. So here's a type of question that a lot of people got wrong on the last test. If it was that simple, it was a little more complicated than that, but if it was that simple, what's the domain of this fraction? Isn't this kind of like what we just did? Except it's all in one function right now. We don't have to try to find 3 separate number lines. But one big number line would help you solve it. Would you agree that one thing it can't be is 7? So then I find 7 and I put an empty spot there. Okay? Can it be everything else? No. What makes the top crash? We got to set that x plus 3, what? Greater than or equal to 0. And on the bottom, you could say, well, was saying, by saying not 7, it was saying x minus 7 cannot equal 0. I solve this, it says x cannot be 7. And if I solve this, x must be greater than or equal to negative 3. So here's negative 3. It must be bigger than that. And it looks like that. Would you be able to do that? And then what's the domain of that? Well, that is the domain. But how do I write that in interval notation? From negative 3 to 7, union with 7 to infinity. That's one thing that we had trouble with on the last test that I want to remind you about. Any questions about that? Yes? Can it be negative 3? Oh, you're right. Good catch. It can be negative 3 because that's on the top. And I can have a 0 on the top. Thank you. And I should have said or equal to, and greater than or equal to are supposed to be filled in. Oops. And then that changes my parenthesis to a bracket. Thank you for catching that. Okay. All right. Now, is one of the kind? Want to talk? Well, first, why is it negative 3? Well, because in here, it works. That's what it's saying is, where does it work? It works between here and here. How do I say that zone? Well, it's between 3 and 7, or negative 3 and 7. It works in there. And if you're not sure, like, why does it work in there? Well, test the number that's in there. What's a number that's between -3 and 7? Like 5 or 4, whatever. Okay, I'll put in a 4, and I put in a 4, and does it work? All it needs to do to work is not crash. It doesn't crash, so hey, it works. So you can always test your intervals that way if you want to. All right, the one other thing that I think you guys weren't awesome at was if I say here's a function. If I say f of x is 0 versus f of 0, they're two totally different things. This one's easy and everybody gets it right. You just stick in what? 0. You stick in 0 and you see what happens. And no matter what happens, that's the answer. Okay? So if I stick in 0, 0, 0, and 0, I get 0 over 8. What's that equal to? 0. It isn't always 0. It's just whatever you get when you stick in a 0. This one, however, means that the whole function, this whole thing, must equal 0. And that'll only equal 0 if what? The top part is 0 or the bottom part is 0? The top is 0. So what would make this equal 0? And a lot of people say, well, 0, and that's it. No. If you can factor it, you should. You factor out the x, and you'd have x plus 1. There's two things that would make this equal 0. What? 0 for this, and what for that? -1. And that's how I can prove it to you. I stick a -1 in here, stick a -1 in there. Doesn't it come out to 0? So there's two things that make it equal 0. And how did I know that? Because I factored it. Because if you can factor it, you should. See? Factoring saves the day again. You're going to see that happen over and over and over again. Factoring, really big deal in math, especially higher level math. The ACT is full of factoring too. They like that it's set up so that, oh, if you factor it, you'll see, oh, it's easy once you get it factored. It's really true. Factoring's big. All right, so there's a couple things that you guys struggled with in the past. I want to make sure that you got those down. And let's talk about the homework for tonight. Pause while I find those pages. So we were in the same file yesterday, but I had you skip this page. Now I want you to do this page. Now notice, it wants you to compute the value. And what am I supposed to do with this f divided by g over 2? Well, first you figure out what the f divided by g is. Here's the f function. Here's the g function. If I'm going to take that function and divide it by the other function, what are they saying with this? What are they saying when they put a 2 there? X equals 2. Isn't that a hint about what parts of those big sets of points you should use? All right. You should be able to figure this out. Just remember, by saying this, they're saying x equals 3. Or they're saying x equals -1. All right. You should be able to put these little puzzles together at this point. I got to leave some challenge if I tell you the rest of it. It's too easy. But if you know that by saying this, they're saying x is -3, then you can narrow this down quite a bit. And by the way, it does say if it exists. So is it possible that the answer is that it does not exist, DNE? Yes, that's possible. All right. Then there's only one other page that we skipped before, and that was this one. And I'm going to add one of these two to your homework for tonight. We're going to do the top one, not the bottom one. You're going to have to actually read through and struggle with, you're in an honors class, a word problem. But in the end, it just boils down to sticking numbers in a function. It's not that hard. That's all I got for you for today.